Black holes are one of the strangest things in existence in our universe. It is of very recent origin. It was coined in 1969 by American scientist John Wheeler as a graphic description of an idea that goes back at least 200 years. At that time, there were two theories of light. One was that it was composed of particles and the other was that it is made up of waves. And both the theories are true now. But if light were composed of particles, one might expect that it must be affected by gravity. So, a consistent theory of how gravity affects light did not come until Einstein proposed general relativity in 1915, and even then it was a long time before the implication of the theory for massive stars were worked out. Now, to understand how a black hole might have formed, we first have to understand of the life cycle of a star. So, let's see what is the life cycle of a star, and from this explanation, we shall explore out how a black hole might have formed. A star is formed when a large amount of gas, mostly hydrogen, starts to collapse in on itself due to its gravitational attraction. As it contracts, the atoms of the gas collides with each other more and more frequently and at greater and greater speeds, and the gas heats up. Eventually, the gas will be so hot that when the hydrogen atoms collide, they no longer bounce off each other but instead merge with each other to form helium atoms. The heat released in this reaction, which is like a controlled hydrogen bomb, is what makes the star shine. This additional heat also increases the pressure of the gas until it is sufficient to balance the gravitational attraction and the gas stops contracting. It is a bit like a balloon where there is balance between the pressure of the air inside, which is trying to make the balloon expand, and the tension in the rubber, which is trying to make the balloon smaller. The stars will remain stable like this for a long time, with the heat from the nuclear reactions balancing the gravitational attraction. Eventually, however, the star will run out of its hydrogen and other nuclear fuels, and paradoxically, the more fuel a star starts off with, the sooner it runs out. This is because the more massive the star is, the hotter it needs to balance its gravitational attraction, and the hotter it is, the faster it will use up its fuel. When the star runs out of fuel, it will start to cool off and so to contract, and as the star contracts, the gravitational field at its surface gets stronger and the light cones gets bent inwards more and more. This makes it more difficult for light from the star to escape, and the light appears dimmer and redder to an observer at a distance. When the star has shrunk to a critical radius, the gravitational field at the surface becomes so strong that light cones are bent inward so much that the light can no longer escape. According to the theory of relativity, nothing can travel faster than light. Thus, if light cannot escape, neither can anything else. So, everything is tracked back by gravitational field. So, one has to set of events, a region of space-time, from which it is not possible to escape to reach a distant observer. This region is what we now call a black hole. Its boundary is called the event horizon. It coincides with the path of the light rays that just failed to escape from the black hole. Anything that tries to escape the event horizon needs to travel faster than light. But practically, according to theory of relativity, it is not possible. So, we can say that black hole is a black sphere reflecting nothing. But if the event horizon is the black part, what is the whole part of the black hole? According to general relativity, there must be a singularity of infinite density within the black hole, but it is not known exactly what would be there inside the black hole. That's all about the black hole for today. In the next video, part 2 of the black hole, we shall explore about various other questions related to black hole, like what would happen to us if we eventually fall into the black hole, how does black hole affect the time, and also various other questions. So subscribe to my channel Celestiosapiens Universe and hit the bell button. Thanks for watching and keep watching.